Good morning, everyone. Today what we're going to look at is how to solve quadratics. Now, before we can figure out how to solve quadratics, we need to talk about what does it take for something to be a quadratic. So a quadratic is when you have the highest exponent as a squared. So in here you can see that this is a quadratic, and this is one in which x is raised to the power of 2, and we even see another x in here. And one thing that you want to be able to do is write these in standard form. Now, standard form is when you have it in descending order from the highest exponent to the lowest. Now, if you're looking at something like this, and I'm just going to give you a jumbled one, let's say we have 4x plus 9 minus 2x squared is equal to 13. I want to be able to get this into standard form, so I'm going to do that real quick by writing this in descending order. And we're also going to want to get a 0 over here if possible. So what I'm going to want is my highest exponent first, and this is my highest exponent. It's a power of 2. So I've got negative 2x squared in the front. Don't forget its sign over here. Next, I'm going to move over its second highest exponent. Well, I can see that this x is raised to a power of 1. And by the way, you only really care about the variable's power. You're not going to care about the numbers that are normal numbers here. Those just get pulled along with the x's. So that gives me 4x to the 1 that comes second, and that is positive. So I've got 4x to the 1, but I don't need to write that. And that leaves the 9 on this side, so I'm just going to do the plus 9 is equal to 13. So once I've run out of my normal variables, I list my normal numbers. Now, I do want this to equal 0, so I'm going to subtract 13 from this side, and that will give me my final answer of negative 2x squared plus 4x plus, well, this is going to be a negative 4 is equal to 0. Now, this is the standard form of a quadratic, right? It is written out so that we have descending order squared first, and then nothing here for the x. And if I wanted to know if something is in descending order, I just quickly check that. I start with the x squared, I go to just a normal x, then I go to one without an x, and it's equal to 0. Perfect, I'm in standard form. So I want you guys to always check if there's standard form first. The reason why is we're going to use standard form to help us with our formula for solving this quadratic. So let's look at that next. Standard form we typically write out like this: ax squared plus bx plus c is equal to 0. Now you can see right here what our variables are. I've got whatever's in front of the x squared, whatever's in front of the x, and then whatever is added on at the end. Those are my a, b's, and c's. And the reason why we want to know these is because these are going to be the foundation variables of our formula. Now, if I had asked you to solve this 2x squared plus 1x minus 10 is equal to 0, you would have run into a problem, because here we've got 2x squared and an x, and no matter what you do, you can't just combine those using addition, because these are unlike terms. That'd be like saying I have 2 apples and 1 orange. How many apples do I have? And you'd be like, well, you've 3 apples if you just like combined them as if they were the same thing, but they're completely different things, so they'd have to be separate. You'd have 2 apples. So don't try to combine the squared and the power of 1. Well, that would mean that if I tried to move the 10 over, I'd be left with an x and an x squared on this side. Or if I tried to move the x over, I'd have this 2x squared and this 10 on this side. And no matter what, I couldn't just get an x by itself. Well, mathematicians realized that this was a problem, so what they did is they made for you guys a formula. And this formula is awesome. It gets the x by itself automatically. All you have to do is substitute in the a, b, and c from the standard form of the equation that you're working with. So let's see what those are, or what this formula is. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I want to point out a couple things right now with hidden parentheses, okay? Because this formula is awesome, but it can be really complicated. And one way in which it's complicated is there are parentheses around the top of the fraction, underneath the radical, and in the denominator of the fraction. So don't forget those. Also, don't forget that we have a plus or minus going on here, so we know that at one point or another, this is going to split into two possible solutions. And that's because in a quadratic, there are going to be two answers that will work for x most of the time. And that all comes down to this little squared. Remember when we were undoing squares, like x squared is equal to 25, what we found is you take the square root and you'd get both a positive and a negative value. So we'd have x is equal to a positive or a negative 5. Well, that's where this plus or minus is coming in front of the square root, okay? So we're going to get two answers because of that squared. Well, let's look at actually how to use this. Now, this one just comes down to taking extreme care when solving your problem. So once you have your equation in standard form, and I'm going to start by giving you ones that are in standard form, what I want you to do is label the necessary variables. And the variables that you need are an a b, and a c. So here, my a, I know is whatever is in front of x squared. So what's in front of x squared is a 2. My b is whatever is in front of the x. And since there's nothing there, be careful there, there's nothing in front of the x, that means it's being multiplied by a 1. So b equals 1. And last but not least, c is equal to a negative 10. So always watch your signs here. These are assuming that these are all positive. So if you have a minus, this is going to have to be a negative. And this one is positive, so it's positive 1. There's nothing in front of the 2, so it's a positive 2. Okay, so I have it in standard form, my first step. I have labeled each of my A, B's, and C's. That's my second step. My third step is going to be I'm going to substitute it into my formula. So here I know I want negative B. So I'm going to start with negative whatever my b is, and that is 1. Plus or minus the square root of b squared, 1 squared, minus 4 times a times c, and a here is 2, c is negative 10. Now all of this is going to be over 2 times a, which is 2. Okay, now take your time writing in your substitution because this is a long formula. Notice how I even followed along with it as I went, pointing them out very carefully because you don't want to do something wrong just substituting things in. This is a really long equation or expression to simplify, and that is not something that you want to do more than once. So make sure that you do it neatly and correctly the first time so you don't need to replace the process. So again, this is going to tell us what x is. So now I'm going to go towards simplification. And here, remember, there are a lot of hidden parentheses. I've got parentheses around the top, underneath the radical, and along the bottom. And when I'm doing my order of operations, I'm going to start with those groupings first, then I'll go to my exponents, multiplication, division, addition, and subtraction last. So starting with my grouping signs, I've got this parenthesis, so I'll start in there, and then I'll actually have to start with my next parenthesis underneath. See how this parenthesis is inside of it? That means that this is where I'm actually starting. So I'm going to start by simplifying that. And here I'm going to start by doing my exponents. 1 squared is just 1 minus. And here I've got multiplication, which will actually be my next step after exponents, right? Multiplication division is next. So I'm going to subtract 4 times 2 times negative 10. So here I'm going to do 4 times 2 times negative 10, and this is 8 times negative 10, or negative 80. So I've got 1 minus a negative 80, and that gives me a final answer of 1 plus 80, or 81. So now I know that what goes underneath the radical sign is an 81. And I'm going to place that back into my formula. So I've got 1 plus or minus the square root of 81, so -1 plus or minus what's underneath the radical, over 2 times 2. Well, this is a parenthesis, so I can actually solve this next if I want. 2 times 2 is just 4. Sorry about that. I didn't realize I'd gotten that low. So 1 plus or minus the square root of 81 over 4 is where we're at now. So I've simplified underneath here. Now I need to simplify the top. The problem is I've got this plus or minus. That means that the equation is going to be split into 2. So I'm going to do that over here where I have the positive version of this equation, -1 plus the square root of 81 over 4. And I'm going to have the negative version of this equation, -1 plus or minus the square root of 81 over 4. Now for both of these, the square root of 81 will be the same. In fact, the square root of 81 is 9. So I'm actually just going to replace those real quick so that I don't have to worry about that multiple times. Now I know that -1 plus 9 is 8. So this is really 8 over 4. And that means that the final answer here is 8 divided by 4, or 2. And on the other side, I've got -1 minus 9. And -1 minus 9 is a -10. And -10 divided by 4, well, we could simplify that to a -5 over 2 or -2.5. Either one of those would work. So that means that these two are my final answers. I can substitute these in for x, and both of them are going to work in my original equation. But we'll save that for tomorrow. That is it for today. I hope you guys have a wonderful day. See you tomorrow.